Hi, everyone. Welcome back. All right. Yeah, let's see. Today we're going to be talking all about state management. But first, let's take a look at where we are. All right. So one of the most important things, the midterm exam is not this week, is next week. I had it. I had the exam listed as being this week, and unfortunately, it's not this week. It's next week. I just want to make sure that all those sections are all in sync. So yeah, so early next week we're gonna go over the questions from prior exams. We're gonna look at sample questions. We're gonna solve them here together. I'll provide a PDF document that has a list of all the questions, and you can take a look at it over the weekend. And then that at the beginning of the week, we'll get together, and a week from today, we'll take a look at the questions. You can bring your own questions, and we'll solve them here together. Those questions are going to be representative of the questions you can expect for the midterm exam, and then later that week, so later next week, the exam will be available. I believe towards the end of the week, and it'll be available for I think 72 hours. In that time, you can take the exam. I think it's about 100 minutes long, and but you do have to take it right there, so you can't pause it and continue on later. So make sure you can find a good chunk of 100 minutes where you can complete the exam. It is open book, right? So you can have access to all the slides and the assignments, any code that I'm about to share with you, or all your assignments you have completed. So yeah, so feel free to use that. The only thing I ask you not to use ChatGPT for doing the exam. Let's see. Right, so that's next week. So the towards the end of the week, we're not going to have a lecture, but I am going to join if you want to take the exam during the lecture. If you want to join and you have any questions, I'll be here the whole lecture time. Again, you don't have to, but if you do want to join, I will be here if you have any questions. What else? So that's next week. So this week, we are going to talk about maintaining state, right? So up to this point, right, we've discussed using HTML and CSS and JavaScript, right? The first month or so, we talked about how to create static content, right, using HTML, and then how to make it look prettier using CSS, right, to change the look and feel, the background colors, the fonts, the layout, make it responsive so that it can adapt to the width of the screen and multiple devices. And other than being responsive, right, the content was static, right? So it did not change. There was no way for us to interact with it at all, right? Again, other than maybe resizing the screen, clicking on hyperlinks to navigate from one screen to the other, maybe pressing a button that would navigate from one screen to the other. But other than that, we weren't able to delete content or post new information or type or anything like that. So when we saw that it was a big challenge, especially if we had a lot of content that was redundant, or that it was always the same content that was used in a whole bunch of places. It was fairly challenging, right? Since we found ourselves copying and pasting a lot, right, from into various HTML documents, and that was pretty tedious, right? As you might have found out, right? And so then since we introduced the JavaScript, right, the whole impetus was that now we can apply many software engineering best practices and techniques where we can wrap content right inside of a reusable function that whatever we call that function, we can then render that piece of content. Right? We can parameterize it, we can pass it arguments, right, so that it can behave based on those parameters, right? And then when we introduce React.js, we saw that we can blend the two worlds together, the HTML syntax, embedded in JavaScript, right, where using a new language called JSX that kind of blur the line between the two, right? So not only could we use a syntax that was we were already well versed of using HTML to generate the content, but we could mix it in with algorithms and functions and modules and components, right, to break up the application into smaller pieces that could then be reused and combined, right, to do more and more sophisticated pieces of content, right? But still it was static, since we still can't interact with what we got so far, right? There's a question in the chat. Just showing, I'm not sure if you mentioned already exam. Yes, we did talk about that the exam is next week, that I had mistakenly scheduled it for this week, and I know it's late next week. This other question is, what part of our project structure gives us access to JSX? Is JSX specifically tied to React? Yes, yeah, JSX is the language, the preferred language in React.js. You can use React.js without JSX, right, where it's all objects and functions. But by far the most common thing to do is to use JSX as the language, and the transformation between the JSX language and the underlying JavaScript that gets compiled is handled by a library called Babel. So Babel, Babel.js, Babel.js is a set of libraries that can transpile, that can compile a high-level languages into lower level ones, right? So for instance, it can compile JSX into the low-level JavaScript. There's a question in the chat. You mentioned this last lecture this Thursday. There won't be a lecture due to the exam. Should I expect there will be a lecture this Thursday? Yes, this Thursday, absolutely. Yeah, this week is like any other week, right? We're going to have lectures on both days, right? Today we're going to do state management using the useState hook. Later this week, we're going to be also applying that to get started with the Canvas application. So we're going to refactor the Canvas application to add state management and add Redux to Canvas to get you going with assignment 4. But next week, at the beginning of the week, we're going to review the exam. We're going to go over several questions that are representative for the exam, right? We're going to solve them together, and then later in the week, we're going to have the actual exam. There won't be a lecture, but I will join in the regular lecture time, and you're welcome to come and do the exam during the lecture time, so that if you have any questions, you can ask during the lecture. You don't have to. You can take the exam at your own pace. Even before the lecture or after lecture. The exam will be available for I think it's 72 hours, starting early that. I think that Thursday, and going all the way to Saturday evening. Is it okay to continue using icons? Yeah, absolutely. Yeah, you can definitely use Font Awesome. React icon, I think it's a much better solution, but absolutely, you can keep using font awesome. All right, so yeah, so we were talking about where we are, right? So, and that the content, even when we introduce React.js, and even though we're using data, we created a kind of like a database, right, that collects several data structures, arrays that contain, arrays of modules, arrays of courses, assignments, grades, users, enrollments. So we have all this data, and then we were able to create algorithms that transform that data into an equivalent user interface, right? So it was dynamic in the sense that we didn't have to copy and paste everywhere, right? We could write algorithms, using loops and if statements and maps and arrays and objects and all these data structures to create an algorithm, a function that basically transformed a static piece of data, right? A data structure converted into a equivalent user interface. So in that sense, it's dynamic, but it's still not interactive. So by interaction, we mean that we want to be able to handle users interacting with the application, typing and clicking and dragging and touching and swiping, right? As they interact with the application, we want the user interface to respond, right? To react to those changes, right? So that if I delete a course, right, or I create a new module, right, or modify the title of an assignment, right, all usually through some kind of clicking some buttons or filling out some forms, right. So we want to take all that data that the user generates, right, and create the new information, or modify existing information, or delete information, or sometimes we refer to as CRUD. We want to be able to create, read, update, and delete. Those are the four basic operations of any data structure that we want to manipulate that data structure, and then we want to see that the application gives us feedback that that interaction has taken effect, right? That if I delete a course, right, then the user interface should re-render, right, and with that course missing, that it's no longer part of the data structure. Right? So it gives us immediate feedback of that. So as I type, I want to see that the actual title is being modified, right? So what we're trying to do is we want to represent the user interface as the state of the application changes over time, right? Because we're interacting with it, with modifying the state. And by state, what we mean by state is a collection of all the variables, right, all the data structures, right, at a particular point in time, right? So at any point in time, an application has a state, right, that uniquely describes, where that application is at, right? And usually there would be a one-to-one representation of that state and the user interface, what you see on the screen, right? And so now that state up to this point is static, right? In the assignment 3, we had a database data structure that collected all these objects and arrays, but it didn't change over time, right? So the state was static. And so we're going to explore today, how is it that we can modify that state, right, as we click and drag and interact. And then we want to see how those changes in the state over time, right, reflect in changes in the user interface. Okay, so yeah, that's the focus of this week. So we're going to first take a look at the use hook, the use state hook that comes out of the box with React.js. We'll identify where it's applicable, where it's useful, and we'll talk about some of the limitations of using the use state hook, and then we'll offer Redux as a as an alternative, or better, a complement, right, to the use state, right? That they both can play a different role, various roles, right? The use state can be useful for maintaining local component-based state, whereas Redux can be used for wider, broader, application-wide state management, right? So we'll first focus on use state in the exercises, right? And then when we come back on later this week, we'll talk about Redux. Okay. The exam next week will include useState hook, but it will not include Redux, right? So whatever we cover up to today, right, will be on the midterm next week, right? But whatever we cover later this week will not be in the exam. All right. Okay. Yeah. So let's see where we are. Right. So we had completed assignment 3 last week. It is due later this week, I believe. And all the assignments were moved a few days, right, to give everybody a few more days to complete. And I believe all the dates have been properly updated. Okay, so let's see. Okay. All right. So the application that we've been building for the last month and a half or so has this combination of labs and the canvas, right? So we're going to focus on the assignment 4 today. And so we're going to follow the same strategy that we used in the prior prior assignment, right? The prior assignment, we worked on the exercises together here during class, right? And like the assignment 3, right, I'm going to share all this with you, right? And you're welcome to use it as your own, right? And I do suggest that you don't limit yourself to just copying and pasting the exercises into your assignment 4 submission, right? I suggest that you practice perhaps creating new versions of the exercises where you might tweak a few things here and there, just to make sure that you do understand the concept, right? And you're not just copying and pasting and memorizing things. Either modify the exercise just a little bit. What happens if I change this variable? What happens if I remove this element from the array? What happens if you have 2 arrays and whatnot? So I would create your own exercise. I think that's one of the best ways to learn, right? Is to create your own questions. If you can create your own questions, then you definitely have control over a particular topic, right? So again, so we're going to go through the various exercises in assignment 4. We're going to solve them. I will give my commentaries on what is the relevance of that exercise, right? How it's useful. Why is it important to know this particular skill? And then I will share it with on GitHub. And again, feel free to use it as your own. All right. Okay. So let's see. All right, so first of all, I'm going to make a distinction between application state and component state, right? So the first set of exercises that we're going to go over, right? They're all going to declare a variable that we want to be able to modify, right? That we want to change that variable, whether it's a string, a Boolean, an integer, or a date, right? We want to be able to modify that piece of information, right? And we want to see that the user interface changes appropriately. Okay, and that variable will be declared within the component, and the changes to that variable are the changes to the state of that component. So that variable or set of variables describe the state of that component. Okay, and we will learn how to change the state of the component, and then it'll change the look and feel of that component. Okay, we're going to call this type of state component state, right? The and really it is, it is enough of just knowing component state to pretty much do anything, but it has its challenges, right? The challenge happens when that state within a component, you want to be able to share it with other components, right? Now, sharing it with your child, with elements that are within the components, is simple because you can pass that state down to the child components, right? As attributes, you can pass that state. You can also pass to those child components functions that can manipulate the state, right? And it can work, very well, this strategy. But quickly you run into a problem, right, or a challenge that when you want to share the data with your parent component, right, or you want to share it with a component that is not directly your child, but maybe is a sibling of yours, right? So how do I share with my sibling or my parent, right? It's easy to share with my children, and the easier way to share it with your parent is to just have your parent deal with the state and not you, right? So move the state management to your parent, and then your parent can share it with you. One general approach would be to, just declare the state, right, at the root of the application, and then share it down to all those child components, right? Now that approach has its challenges, since oftentimes your components will have multiple layers of kind of like a tree structure of components within components within components within components, right? And at the end, you have these leaves. And so the challenge is that that oftentimes, you have the state at a very, very high level, but the actual rendering of that state happens at the leaves of that tree, right? And oftentimes nobody in between cares really about the state, but nevertheless you have to pass it down to your child, and the child needs to pass it down to the child, and then that child needs to pass it down to the child, all the way down to the leaf where the state actually is needed. Okay, and so you end up with this accumulation of attributes that are being passed down to the children, which can cause a headache of maintaining all these attributes, especially because all those intermediate elements don't really care about that state, right? They're just declaring these attributes so that they can pass it down to the children. So you're adding all this extra code, right, without really needing the having any effect on a particular component. And so this problem is generally referred to as property drilling. You're just drilling down, right, down the tree and the hierarchy all the way down to the leaves of the tree, right, where the actual state is needed, all the properties are needed. And so this causes a lot of dependencies between the children, right, and their ancestors. And if you want to move an element, right, from within a particular hierarchy of the object of the application, you want to move it elsewhere, or you want to reuse it somehow, well, you have to be careful, because now you'd be breaking the dependency flow of the data, right? And if wherever you're going to put it, you're going to have to recreate that dependency of providing the data all the way down to that component. So it makes it really, really hard to re-architect and move things around in an application. So to solve that, we looked to break up that dependency between the state, right, that is flowing up and down, and the dependency of where the where the information is needed, because I need to render it, right? So those are two separate issues, right? Maintaining the state and rendering that state. And right now, they all live in the same place in the component, right? You're maintaining the state in the component and you are rendering in the component. So we want to break up those two concerns, right, of maintaining the state outside of the component, right, and then somehow the component needs to access it for rendering purposes. So we need like a in particular state that is needed across an entire application, right? And that's where we're going to be talking about the application state, right? This is state that is application wide. For instance, if you log in, right, you want to keep track of the person who's currently logged in for the whole application, right? Not only for the shopping cart screen, not only for the checkout screen, right? Not only for my profile screen. I want to know, and in every single screen, I want to know who's logged in, right? Because I want to show them, ads, or I want to show them their shopping cart, right? I want to show them their checkout. They want to show them all sorts of things, specifically for that person. So this is information that is available across the entire application. So how do we do that? I mean, how do we share data across multiple components, right? So and for that, we're going to introduce Redux as a library that can solve this problem, right, of breaking up that dependency. Okay. So first, let's tackle the simple case, right, of talking about the component state, right? So let's use some labs, some simple labs to illustrate what the problem is, right? What the out-of-the-box solutions of using the useState is, right? And then where are its limitations? Okay. All right. Okay. So let's work on a few exercises, and so we already have the assignment 4 already built, right? And that it's available in the labs. Or we already have that. Right, so we already have in the labs, we have links to go to assignment 4, right, and then the routes that render the various assignments. We already have that. But if you don't, right, the assignment does suggest that you create kind of like a navigation component that you can then add to your lab so that you can navigate to the various components. So if you haven't done that, please do that. Okay, so let's first tackle some really trivial aspects, right? Notions, right? That you can pass attributes to components, right? So let's create on assignment 4 folder an add.js that contains a component that can take as arguments 2 attributes or 2 properties, A and B, and it renders just the values that you're passing plus the arithmetic addition of those 2 values, right? And we probably what we want to do is we'll put these together side by side so we can see what's going on. So let's put this side by side. Maybe not. Is this? Oh, code. Sorry. I'll put it here. There we go. There we go. So this is assignment 4. Let's go to assignment 4. There it is. So let's do some exercises for assignment 4. And let's include it in our assignment 4 component. So we'll say add.js. Oops. Add.js. And I'm going to pass values of 1 and 2. And there it is. It renders just fine. Okay. So let's just look real quick. Just go over this real quick. Notice that this is using the destructor syntax, right? So it's expecting that we pass it an object with keys A and B, right? And that's exactly what's happening in the assignment 4, right? We are using attributes, the attribute syntax, and what Babel does, right, is that it creates a object out of this where the keys are A and B, right, and the values are 1 and 2. So it creates an object with properties and values, right? And it passes it to the function as a whole object. And then inside the function, we destruct that object, associating the values to the local constants A and B. And then internally, right, it's just the same, right? We render the original parameters 1 and 2, right? And then we render the result. Everybody good? Okay. All right, so that works, right? So nothing new there. That this should be very easy for you. Okay, so let's go on to the next one. Okay, so here's one more interesting is we want to learn. Oh, there's a question. Why can't we use A = 1 and B = 2 without the right? Because the way this works, right, is that it's equivalent. This is equivalent to doing this. Add A 1 and 2. Like that. See that? So this is identical to calling the function with an object of A1 and B2, right? And so in here, you could retrieve, this is an object that we're expecting. Here's the object, OBJ, yes? Here's the object. And then here you can say A is OBJ A, and then B is OBJ B. See that? And works just the same. It works just the same, right? But there is a syntax that allows us to abbreviate this, right? So instead of doing this, instead of doing that, we can do this instead, right? We can say const like that. See that? Const A B and then OBJ. See that? Or we can go even further, and we can just use this syntax right there, and do the destruction right in the receiving end of the function. Does that make sense? Okay. Yeah. So let's handle events. So we want to be able to click on buttons. I want to click on something on the screen. I want to be able to type. I want to be able to select dates. I want to be able to do checkboxes. I want to interact with all sorts of form elements. Fill out text areas. I want to fill out forms. Right? And then we want to be able to grab those events, all that stream of events that we generate, that presumably has an effect on the data structure and the data, right? And then that data needs to be reflected in the user interface. Yeah. So first, let's see how we handle events, right? And the simplest of events is the click event, clicking on something. So let's create a component that can illustrate this click event. Let's copy that and let's take a look at it real quick. So if here we're declaring two functions, right, that we are going to invoke when we click on buttons, right? Both of them just alert, right? Just pop up a little alert. And the way we're invoking them, right, is that we're declaring three buttons, right? And let me just include that here. Say include it as in click event. All right, so there it is. So it's three buttons that if I click on the first button, it calls the function hello. So there it is. Here's the hello function, right? It's going to alert hello world. So if I click on it, there it is. It pops up. It says hello world. Pretty simple. I do want to point out the syntax, though, of how we're invoking the function. Notice that it just says hello. It's a reference to the function. There are no parentheses here, right? It's just the reference to that function. Everybody good? Okay. And I do want to distinguish it from this other syntax, right, where we are using the parentheses, okay? And Now, because I am not passing any parameters to the hello, well, not that I'm not passing, I don't need to pass anything to these to this function, right? I don't really need to use this syntax. I could just use this syntax because I'm not passing any parameters. But if I were passing parameters, then I do need to use this syntax here. Okay. What I don't want to do, by mistake, right, is put a parentheses in this syntax like that, right? I'm not going to save the file because if I save the file, this is going to enter an infinite loop, right? This function call is going to cause the component to re-render, and the re-rendering is going to cause the function to be called again, which is going to cause it to re-render again. So it's going to end up in an infinite loop, right? And the only way to get out of it is to kill the browser, right? So careful, don't do that. If you do need to pass parameters, then use this. What you do is that you wrap your function call, right, inside a anonymous function, right? Now, this is often referred to as a closure, right? It's a JavaScript function closure, right? And what it does is that it keeps a snapshot, right, of the current state of the application at this particular time, right? So it remembers, right, what everything was at that particular time, so that when the event actually happens, you can recreate that state, right, and call that function in that scope, right, in the scope of with the state that was when this was created. Right? We don't care about that right now. In later examples, we are going to care, right? All right. Also, I'm pointing out here is that this syntax has no curly brackets. See that? No curly brackets. So this is actually an implied return, right? So whatever hello return, if it returns anything, is being returned, right? But it's also only for one single line of code, right? Only hello. If you do need to invoke multiple lines of code, like 2 functions, or maybe you want to put here a console, right? You want to create multiple lines of code, then you do need the parentheses, the curly brackets, right? To wrap that and create a body to invoke. But nevertheless, it's a bad practice to make this too busy, to embed a whole bunch of lines of code inside of a button click, right? It's better to just have a call a function that handles, right? And here you can have as many lines of code as you want, right? That's totally fine. But nevertheless, the syntax is there. Everybody good? Everybody understand the difference between the syntax, right? It will be in the exam, right? This syntax. I'm going to try and fool you, right? And I'm going to ask you to see if, I'm going to deliberately add a parenthesis here, right? And I'm going to ask you, is that okay? I'm sorry. It says, so do line 11 and 12 have the same purpose? Yes, absolutely. These 2 lines do exactly the same thing. So they both alert and call the hello world. There's no difference between the 2, right? So they're entirely equivalent to each other functionally. And the last one calls both of them, right? First calls the hello world, right? And then the second one is life is good. All right? Okay. All right, so let's move on. So what if you are actually passing data between, right, a click event and a function? So let's illustrate that. Let's paste that in there. So there it is. So here's a little function that, in this case, I do need to pass parameters A and B, and it's going to alert, A plus B is equal to A plus B. And in my button, I need to pass the add, right, with values, and careful not to do this, right? Just add and call it 2, 3. That is going to cause an infinite loop. So I'm not going to save my file. I'm going to remove that. Oops. Yeah. I'm going to remove that. And there's my on click that calls my add 2, 3. Okay. Let's save that. so that, and let's include that in our assignment 4. Assignment 4. So let's see, passing data on event. There we go. That. Did I pass data on event? Why is this not rendering? Oh, there it is. It took a while. So that if I click on it, it just alerts that 2 + 3 is 5. Okay. Questions here. Hi, Professor. Can you provide an example where we have some parameter for the first? You mean here? Are you talking about here? Not sure what you mean. Yeah, no, in this case, we don't need a parameter, but we could have a message. This could be a message, right? And I would pass in the message, hello world, right? And then I print out the, I print out, this could be maybe, right, something that says, it says message, and then, we embed the message in here, right? So now if I click on this, if I click on that, it says message hello world. The second one is not going to have it. Actually, what it's passing it is that all these functions actually are being passed an event that we are ignoring. We are ignoring that event, but it is being passed here directly as an event. Let's see the question. Method. What we seen so far is some parameter for the parentheses after the method, but what is the purpose of the first parameter if we are passing the parameter in the second one? Oh, you mean this one? You mean this one over here? Oh yeah. So this is now we're passing. This is a function, right? Just like when you declare a function here, just like that. Right. So you are basically declaring a function in here that has the body of a function. See that? Right. Just like hello is a function, right? That that we're just now either referencing it here, or we can embed it in there. Or we can embed it right inside of the onClick. Okay. All right. Okay, so passing. Right, so here we have the example that we click here, right, and we pass a 2,3. So careful that we don't forget to put the the closure in there, right? Otherwise, we end up in an infinite loop, right? I'm just driving the idea home, right? To be careful. Notice that I'm highlighting here to remind you not to add that, right? To remove it. You're passing functions as well. So this one's a little more involved, right? A little more weird, perhaps. So we're passing functions here. So in JavaScript, right, functions are just as important as variables. They can be treated as such, right? So everything you can do to a variable or a constant, you can also do to a function, right? So including passing it as an argument, as a parameter, right? So for instance, in this example, we are being passed, right, in the attributes, we're not being passed an integer or a Boolean or string or any primitive data type. We are being passed something of type function, right? And and just like certain data types have different operations. If this were an integer, I can add them, subtract them, multiply them. If these were a Boolean, I could AND them, I can OR them, I can NOT them. If these were strings, then I could concatenate them, right? I could print them, right? I can search through them, right? But if this is a function, the operation in a function is to invoke that function, right? Or you can pass it parameters, right? So every single data type has a different set of properties and affordances, things that you can do with them, right? So functions can be invoked, right? So wherever a function can live, I can use this function that is being passed to me as a parameter. I can use it anywhere. So for instance, if we have a button that if I click on it, it's going to invoke the function that you're passing me as an argument, right? Now, on the other side of the assignment 4, we can bring in that passing functions, right? And we can declare a function. We can say const, say hello, and this says alert hello, right? And then we can pass it the function here, the function, and then there it is, say hello, yeah. So that if I click on it, I'm going to call the function that we pass it. There it is, hello world, yeah. I can also just declare the function in here. I can just create the function right there, right? It says alert, life is good. Why are we adding so many? Wait, there we go. Okay, so notice that the function, I am declaring it right there and then, and that's what I'm passing to the function, so that if I click on it now it calls that one, that other function, life is good. Make sense? Or this one can also call the one here. Right, so then it would first invoke life is good, right? And then it would call hello world. Make sense? Right. So yeah, so functions can be passed around like any other variable. Okay. All right, so let's go on. All right, so also an important aspect of working with event handlers, with these functions that are handling our events, our clicks, is that when your function gets invoked, an event object is passed. Up to this point, we have been ignoring that event object, right? But it's a very useful object, right? It collects a lot of meta information about what was going on when that event occurred, right? When you clicked on that button, what time was it, right? What is it that you clicked, that button or that other button? Was the shift key pressed, or the alt key, or the command key, right? Where was the mouse, right? X, Y position, right when you clicked, right? So it collects all that meta information, right? And it passes it to you. You can do it with it whatever you want, right? We in particular, mostly what we're going to be doing with it is that we're going to be using it in the input field when we're typing. When we're typing, right, the value of the input field of the text that you have typed so far is available in that event. Okay, the event has a reference to the DOM element that generated the event. In a button, it is a reference to the button, but in an input field, it's a reference to that input field, right? And you can say, oh, I have a reference to that input field, and you can query it. You can say, what is your current value, right? And then we can use that data to, save it or whatever, right? So let's take a look at it, what it looks like. So let's create the event object. Let's create a new file, event object. There it is. And let's copy this in there. And let's include it in our assignment 4. Event object, I think that's it. So there it is. So event object, right now it says null. Okay. And so what we can do is that we can, let's take a look at the code first. So here's our event object, here's our button, right? That is going to, we're going to click that says, display the event object. And when we click on it, notice that the function here, right? Whatever function you give it, right? It's going to call that function. Here, this is the function that we are giving it. That's the whole function that we're giving it. And whatever function we give it, right, it's going to call your function when you click on it, and it's going to pass an event object, right? Now, you can ignore it, and we have been so far, right? We have, we have been just doing this, right? Nothing. It has been passing it to us, but we have just been ignoring it. But this time we can grab it. We can say, oh no, I do care about the event object. And what I'm doing here is that I'm just passing it to my local variable here, event click, right? So here's the event object, there it is, right? Because I want to display, I want to see what it looks like, right? Now we could just do console log E. That would be enough, I guess, right? We print it on the console, the whole object. But I wanted to just push it a little further. I wanted to display it on the screen. Now, displaying on the screen has a little bit of challenges. One of them is that the event object has references that would cause an infinite loop if I try to render it on the screen, right? For one, it has a reference, it has a property called view, right? That is a reference to the window, the overall window of the browser, right? And the window of the browser contains the button, yes? So if I try to render on the screen the view is going to try to render the button. And the button is going to try to render the view. And the view is going to try to render the button. So it creates a cycle, right? Well, it's not going to try to render it. It's just that there's a cycle, right? The cycle is that the button has a reference to the view, but the view has a reference to the button, right? So that's a cycle. So I need to break that cycle, right? And so I delete the view. The other thing that's in there is the target. This is also a reference, right? Because it's an object that gives us a reference to itself. Target is a reference to the object that generated the event. Who? The button. So this also creates a cycle. So what I do is that that DOM element, right, the button DOM element, I'm just asking, well, I just want to look at the HTML, right, as a string. I don't want to work with the button directly. I just want to see the HTML, right? So I just replace the reference with its text representation in the DOM, right? And then what I do is I store the event, right? I store the event in this state variable, which we don't know what it is yet, right? But it has the effect that when I store it in the event object, I can then just print it to the screen, right? So let's see what it looks like. So let's print it. So there's a lot of information there. So in particular, there's a timestamp, right, of how many milliseconds have occurred since, I don't know, 3 million seconds. Has also the where the XY position of the screen was, of the mouse, whether we had the control key pressed, right? I didn't have any keys pressed, but if I did, say I press on the shift, notice that the shift becomes true. If I press on the command, maybe that's control. Oh no, command. There it is. So the command, there is the meta key, right? Is the command key on Mac OS. Anyway, there's a lot of information here, but in particular, it has a target. See, that target is the button object that I clicked. So we have a reference to the button. Notice there it is, the text, right? To display the event object, right? Display the event object. That object is there. Cool. Anyway, so we're only going to be using this for the input fields to grab the value of the input field. All right. So anyway, so we talked about the set env, right? That was setting the that the state variable. So let's talk about a state variable because we haven't discussed what a state variable is, right? Okay. Yeah, so let's see. I guess another useful example would be, right, that question. Professor, could you please explain the set env again? I am. Yes, that's the next topic. We're going to talk about the topic is the useState hook. Yep, we're going to talk about that. Right. So up to this point, right, we have, excuse me, been looking at how to handle click events, right? And but we haven't been modifying the state of the component just yet, right? We don't have variables that we have been able to change. Let's look at that, right? So imagine that I build a counter, right? Say I build a counter. Okay, and that counter declares a variable like that. Declares the variable count, right? Declares the variable count. And let's oops, what's going on here? Okay. So let's load that counter in the assignment 4 component. So counter. And there it is, right? Here's the counter. And for this one, we'll need the console. So here's the console. And there it is. So here's my counter, and here's my console. So notice that in my counter, I have, here's my header. Notice that it's displaying 7. So it is displaying this initial value for my variable. There's a question in the chat. It says, hi, brother, can you explain what the delete eView does in the handle? Yeah, so what happens here is that the event has a property called view. And view is a reference to the window, right? The whole window, right? The browser's window. And so if I try to print this in the JSON stringify, the string, it's going to complain saying that the button has a reference, right, to an object that is the view. But the view is the window. It's the overall window. The window has a reference to everyone else, including the button, right? So when it tries to print it, it ends up being a reference cycle, right? The button references the window, and the window references the button. So it would, if it tries to print it, it's going to end up, in an infinite loop trying to render that forever. Right? So the printing mechanism identifies this, and it doesn't print anything. So I remove the reference so that I remove the cycle. Okay. All right. So let's look at the counter. So the counter. Notice that the variable here is declared as 7, and we are rendering this 7 right there. Yeah. And also I'm declaring 2 buttons, right? One up button right here, and one down button right there. And the up button, notice that when I click on it, right, what it wants to do is that it wants to increment the value of count, and then print its value. Whereas if I click on the down button, right, it wants to decrement the value of count and then print the new value of count. Yes, right. So let's see if it works. So notice that if I click on up, notice that the console, it's showing that the variable is indeed changing over time. Right. Same thing if I click on down, right, it goes down, right. It is changing over time. So it's the evidence is there that we are indeed able to change the variable. But notice that the user interface did not change right? See that even though the variable changed, the user interface is still shows that it's 7, okay? So that's a problem. Why is that happening? Well, the reason it's happening is that React.js uses what it's called a virtual DOM, right? So what happens is that using JavaScript to modify the DOM, right? So remember, there's a data structure. There's this data structure here, right? That represents the entire HTML document, right? And we have been learning that JavaScript can manipulate this data structure using the document.write, right? Using React.js and whatnot, can inject and manipulate this data structure. And now, directly manipulating the data structure is very expensive, right? And very inefficient, okay? So what React.js does is that it creates a more compact, more efficient version of the DOM in memory, right? Called the virtual DOM, right? And then what it does is that it makes changes. It manipulates the virtual DOM, which manipulating the virtual DOM is several orders of magnitude faster than manipulating the real DOM, right? But the manipulation is equivalent, right? And so once the DOM is manipulated, it can batch these changes to the virtual DOM, and then at some point, right, it needs to do the rendering. It needs to say, oh well, okay, I have enough changes to the DOM accumulated. I'm going to find a good time to go in and actually dump and convert the virtual DOM into the actual DOM so that it can actually render on the screen. So changes to the virtual DOM are not immediately visible on the screen. Not until the virtual DOM gets converted back into the actual DOM, then we see the changes on the screen, right? So this is actually a very, very common strategy, right? When we try to optimize changes to something that is time consuming, right? For instance, databases do something similar, right? Databases, they try to minimize the times that they have to go out to the file system, for instance, right? Going out to the file system to update a record, right, is extremely slow, right? It's several orders of magnitude slower than doing the same operation in memory, right? So what databases try to do is to, grab chunks of the database, right, and cache them in memory, and then do all the updates in memory, all the inserts, all the updates, deletes, right? Now, at some point, those changes need to be written back into the file system, right? But the database, what it does is that it postpones that writing to the file system as long as it can, right? Again, to optimize the performance of the database, right? When it's absolutely necessary, it will go and actually dump the data into the file system. Okay? So it's a very common strategy of caching, right? Very slow, very inefficient processes, caching it in memory, doing the changes in memory, and then dumping it back, right? So that's what the virtual DOM is doing. The other strategy that is also very common, and you see this in rendering engines, graphics cards and things like that, is that you have a data model in memory that represents some graphical representation, some 3D world that multiple users, multiple players are walking around, right, and interacting, right, and maybe they're playing and they're trying to find each other and whatnot. They're competing, and so you have the data model that represents the world, right, in memory, and then you have the rendering representation of that graphic representation, and so the question is always, when do I want to do the rendering, the drawing of this data model, right? When do I want to do actually the rendering on the screen and render the screen? So usually there is some kind of function that the game engine, some API allows you to say, oh, well, this is a good time for you to render the screen, right? And usually this is done in a very tight, loop where you're computing where all the players are, where all the vehicles are, right? And where all the enemies are, right? And everybody's moving, and you're up, and you have all these variables and all these data structures keeping track of what's going on in the game. And then there's a function that you have to call, well, draw, draw all this data structure, actually draw it on the screen. And you have to do this, 60 times a second or 100 times a second, so many, so that the game is smooth, right? So we do need a mechanism for modifying the data, and then to notify the rendering engine that this is actually a good time, an appropriate time, right, for actually updating the screen. So these two ideas, right, the caching, the virtual DOM, right, in memory, and then, right, being able to notify when things should be updated. Okay, so how do we bring those two ideas together? Well, how is that relevant here? Well, the way it works here is that we need to tell React.js that this variable here, right now it's being ignored. But the DOM is ignoring this variable. It's not rendering changes in the DOM. Right? So we need to be able to create a data structure and say, well, so that we can tell React.js that the changes to this particular variable is important and should be worthy, right, of updating the screen, right? We're telling them, don't ignore changes to this particular variable, right? And the way we do it is as follows, right? What we do is that we use what is called the useState hook, right? And so it's a function that we call that function, and then it returns a variable that you can use like any other variable, that just like any other, just like a count, for instance, right? So notice that this count, there's no functional difference between this count, being declared simply with a let or with these funny looking square brackets, right? So this works just the same, right? So I can go up and down, and up and down. So it works just the same, right? It's initialized at 7. It is initialized at 7. See that? Just like before. So no difference. The difference is that along with the actual variable, we also get a function that is going to allow us to both update it, right, and tell the rendering engine that, hey, this is a good time for updating the screen. Go ahead and update the screen wherever this count is rendered. Go and update the DOM, right, and make sure that it's displaying the latest version of this variable, right? So we would have something like count, set count. Now this function is how we're going to update the variable so that we can notify React.js that the change should be rendered. So instead of using direct manipulation of the variable, we're no longer going to do that. Instead, we are going to use the set count, right? And what we do is that we compute a new version. We compute a new version of the variable, right? So usually based on the previous variable, right? You say set count to whatever it was, +1 or -1, right? but now, right, the up works. See that? So when it's changed, the rendering engine is notifying that, hey, something happened to the state variable. Go ahead and update wherever this variable appears, right? But decrement doesn't work. Decrement still doesn't work, right? So we can, change it so that it uses count -1, so that now it does work and it updates up and down. Now, it doesn't necessarily need to be, based on the previous value. You can have a button that just resets it. Let's say reset it. So button, reset. And this would be, on click, we call the set count to 0. Right. So for instance, if we click on reset, it just sets to 0. So this one has nothing to do with whatever value, right? Whatever value it was originally. Okay. Also, right now it's being only rendered here. Okay. But we can have any number of instances of where that variable appears. So say we have this H3 smaller versions. So there it is down here. And notice that both are being updated, right? It's kind of like a broadcast, and it's keeping track of which elements, which DOM elements are dependent on that variable, right? And if that variable changes, it goes in and iterates over all the DOM elements that are dependent on this. Okay, so imagine doing this with plain old JavaScript. If you're doing this with just plain old JavaScript, or even with jQuery or anything like that, this would be a nightmare, right? Because you would have to have some kind of array if you keep track of all the places where this rendering occurs, right? And you have to, invoke and update all these DOMs, right? Which is a pain. And so you would need some kind of a broadcast or some kind of a subscriber or like an observer pattern, right? Where that they all enlist into the observing these value, and then they update the various places. So it's not trivial. So it's a great little behavior. You can render it wherever we want. So here's counts. You can put it maybe next to the buttons, right here. So now wherever you update, right, wherever you reference that variable, it's just being notified of the new change, and it updates the DOM. Now it doesn't re-render the entire screen, right? It's only updating those pieces of the DOM, right, that depend on this, right? So it's trying to optimize so that it doesn't have to re-render the entire screen. It kind of does a very surgical change in the DOM, right, before it goes out to the virtual DOM, before it makes changes to the actual DOM. Make sense? Right? Okay. All right. So let's okay. So now let's explore various data types, right, and how to work with these new state variables, right? So we're not going to call them anymore just plain old variables, right? We're going to call them state variables, because they are variables that maintain the state of the component, right? And as they change over time, they reflect on changes in the user interface, right? So let's take a look at this example where we are going to work with Boolean variables, right? So let's create here a Boolean variable example. Okay, and let's copy and paste that in there. There it is. So let's bring in this new example, this new exercise into our assignment 4. This is a Boolean state variable. Okay. So here's a Boolean state variable, and notice we have a checkbox, right? If we click on the checkbox, notice that it changes this text here, right? It changes the text to done or not done. Also down below, it hides and shows right? This alert down below, right? It also updates the state of this checkbox, right? So let's take a look at how this is implemented. So here it is. So here's a new state variable with its set done, right? And it has this initial value of true, right? So done is initialized to be true, okay? And what we're doing here is that so this is something that we know about already, right? We've done this before. That we are displaying either one string or another based on the value of a Boolean expression, right? So if this is true, then it renders this whole thing renders as done, right? If this is false, then it renders not done, right? And so basically we want to be able to toggle done, right? And we're doing it using this input field over here, right? So this input field is of type checkbox, right? Type checkbox, and what we're doing here is that the done Boolean flag, right, is driving the fact that this input field this checkbox is actually checked or not checked, right? So if it's true, it's checked. If not, it's true, it's not checked, right? And that's why you see this being checked or not. Also, it's set to on change, right? So on change is a new type of event handler. So we've seen on click, right? And now we have on change. Now there's a whole bunch of event handlers. So if I say on, here we have a list of all the different types of event handlers, right? On blur, on play, on click, right? On double click, on copy, on cut, right? On drag, right? On whether you're entering, whether your mouse is entering, the mouse is leaving, right? On if there's an error, right? So there's a lot of the keystrokes. You can listen to everything, single keystroke. So it's a whole bunch of on event handlers. But the ones that we're going to be using mostly in this class, right, are the on click and the on change, right? So on change is invoked when the input field state changes, right, from checked to not checked, right? And so what we're doing is that we're running a piece of code, right? We're calling this set done to toggle the value of done, right? We're setting done to be whatever the negation of it was, right? If it was true, then it becomes false. If it's false, it becomes true, right? Notice that if we did not have this on change, if we commented out, notice that this would not work anymore. See that? Because the state of being checked would be forever, right, tied to the value of done, which is true. It's always true. Nobody is invoking set done. Nobody's changing the state, so it is forever checked, right? So there's no way to uncheck it. Now, if I click on it, it wants to change. It wants to change. Notice that if I instead of doing this set done, I do an alert and says, yeah, you clicked me. Yeah, yes, it changed. Right? So I click on it and it says, yes, I've changed. But they're not letting me transition to the other state because somebody's telling me to always be checked. Okay, that's the problem. And the actual value of the checkbox, actually, that's a good I'm gonna leave this as set done. Let me put it in another checkbox. Put in a different checkbox here. Okay. Check done and type checkbox. So let me show you that the event object actually has an e.target dot, I think it's checked. Yeah, checked. right? So this is the state that the checkbox wants to become. It knows that it's checked, and the state that it wants to go is that it's not checked, right? So that if I click on it, notice that it appears as false, meaning I am true, I am checked, and I want to become false, but they're not letting me. They're not letting me because I am forever stuck at done, right? So what we could do is to update and set done, right, to target, to change the state to what it actually wants to be, right? So we can set, so if it's false, right, it's become false, and then it becomes true, right? So if I click on it, notice I now have two checkboxes that can drive the same set done. So there's two ways of doing it. One is to directly sending the done, right, to the toggle, okay? But this is more error prone. Say you forgot the not, right? If you forget the not, this is never going to change, right? Because from true, you're sending it to true. Or if it's false, right, it's still going to be false, right? So you have to remember to toggle it, right, to invert it. Or you can say, well, become the state that the input field wants to become, right? All right, okay. Which is very similar to what we're going to do with the string variables, right? So let's take a look at string variables. So let's see, string variables. And let's copy that in there. Let's paste that. And then let's add it to our assignment 4. So here's, we have a string variable. There's a question on the chat. So why it is controlling two checkboxes at the same time? We needed to control separately. Do we need to declare two? Yes, exactly. It would be two separate state variables. Right now, they're both, the example that we're looking at, they were both driven by the same state variable. Very, very good point. Yep. Exactly, very good. So you have a string variable. So there it is. So we have John. Excuse me. And so we have a first name that is initialized to John, and we're displaying it here maybe as H4. So here's John. And the input field, right, has an initial value. It's being initialized to whatever first name is, right? And as we type, every keystroke is going to generate an event saying that, hey, you want to be, whatever your value was, plus this new character, okay? And it's passing it to you in the e.target value. So if I start typing, John, N and Y, so I'm typing every single character. So that new character, right, is being appended to the old value. So it becomes John N, John N, John N, right? So every single character is being sent over in the e-target. And what we're doing is that we are updating the state variable, right, with this new accumulation of characters. Notice if I didn't have this on change, right, this would forever be whatever that variable was, right? That in this case is John, and I would not be able to type it, right? I won't be able to type it. So we want to be able to grab the actual value that it wants to become, right? And say, yep, I will let you, right, update the state variable based on, right, what you want to become as you type the keystrokes. Okay. Make sense? Yeah, very similar to the checkbox, right? All right, so let's look at date state variables. So date state variables, the only challenge with date variables is that JavaScript and HTML represents dates slightly different, right? In HTML, the date pickers, they want their the date represented as year, year, right? Month, day, right? And whereas JavaScript represent them slightly differently, right? So let me show you. Okay, and let's add it to the hello world. So date state variables. So we have a start date, right? That we are initializing it to the current date, right? Which is 2023 October 18. I think that's correct. Okay. But then by input field of type date, right, wants the value to be represented as month, 4 digits for the year, 2 digits for the month, right, and 2 digits for the day, right? So I created this little function that can convert between the two, right? The date object, right, and I'm converting it into a string that has the 4 digits dash 2 digits for the month dash then 2 digits for the day, right? This is also exercise on learning about the date object itself, right? Giving you the various functions, right, that are useful for extracting the various pieces of a date. And I'm just building it into a string that is compatible to what the input field type date wants to be, right? Now, as you change the dates, right, the new value for the date is passed in the event, right, in the eTarget.value, which I am using to create a new instance of the date, right, and set the start date again. So that if I click on this, right, 10th, notice that the new date object updates, right, November 10th. See that? So that works. Other than that, right, I could have probably just used this. Although I don't know if this becomes, let's see, if I go into, say, October, September. Oh yeah, see that? This is already in the correct representation. So I could have just used that, right? And the date representation has a string representation of the date object. I could have just stripped out everything, the T and following, and use that, right, as a string to update my my HTML, right? So this is an overkill. This is absolutely an overkill. Right? I could have implemented this so much easier. Although this gives us a chance to play around with the functions of the date object. Right? Okay, so let's look at object state variables. So object state variables. So what allows us to do is to work with not just primitive data types like strings, integers, Boolean, right? But with complex data types where we can combine multiple data types together into one collection, right? We can aggregate data types into one single object. So here we have we are representing a person who has a name and an age, right? 2 properties to keep it simple. And then we are going to include it in our assignment 4. So this is object state variables. So I'm just simply declaring 2 input fields that are going to allow me to modify, each individual property in the object, right? One for changing the name, and another one to changing the date, the age, right? And then I'm just going to re-render the person here as a JSON stringify object. Okay. Now the input here, one for modifying the person's name. Notice that it's initialized to person.name. See that? So we can grab the value of Peter, right, and then render it for the input field. Now notice and then we did the same thing for the input field, right? Probably this should be of type number, right, so that we maintain the correct data types. So now for the updates of the person's name, right? I am I want to change the person's name, right? But not any other property, right? Only the name. I don't want to change the age. I don't want to change their address or anything like that, right? So what we do is that, to set the person, basically we are going to compute a brand new object based on the old object, right? So for instance, what we're doing is that our new object is going to contain all the old values of the person, right? Meaning the old name, right? The previous age and whatnot, right? We're going to keep all that, but then we're going to override a specific property, in this case, the name. We're going to override the name so that, because we don't want the old name, we want to update it to be whatever the input field says, right? We want to change it to that, right? The same thing, we are updating the age, right? We're going to create a brand new object, right? And we're going to copy the old values of the person, but then we're going to override that specific property age, right? To be whatever correct data type is. We're going to parse whatever value you're typing, make sure that's an integer before updating the person's age. Make sense? Right? As opposed to what I see oftentimes, students will create an event handler for the name, another event handler for the age, right? And they'll create all this very complex logic when it's fairly simple, right? It's just copying the old and then overriding with the new value. Okay. All right. Right. And so here it is. So let's look now at an array, right? An array data state variable, right? So let's copy that. And let's paste it in there. And let's copy that in here, right? Yeah, so this is a simple array of just plain single digits, right? So let's add this exercise to assignment 4, array state variable. There it is. So there it is. So it says it's an array. It's rendering the values of the array that we just have numbers 1 through 5. There it is. You can delete individual elements. You can add random values at the bottom, right? You can delete those new ones, right? Or delete the first ones, right? Let's look at the implementation. So declaring an array, you already know how to do that, right? And we are just initializing our state variable array right here. We have the setter. And we are, we're just rendering each one individually as a separate line item and the value of the item, right? 1, 2, 3, and so on and so forth. But then we are declaring 2 buttons, right? One that invokes the add element function here, whereas this another button invokes the delete element function also over here, right? Now the syntax is slightly different, so let's look at the simple one, the add element. So the add element, notice that it's using the syntax of parentheses, right? Because it doesn't need any arguments, right? It has everything it needs inside of the function, right? So what it's doing is that it's computing a new array. So this is a new array. There it is, a brand new array, and then setting the array to this new array. So it's overriding the old array with this new array. Okay. Where the initial values of the array are the old values of the array. So in this case, 1, 2, 3, 4, 5. But then comma, right? It is appending at the end of the array a random value from 0 to 100, right? And then you see it being added at the bottom, right there, right? Now, some people find it hard to read this syntax. So if it helps, you can separate these two into 2 statements, right? So the new array would be, this statement, and then you just do here new array. Maybe that's easier to read for you, right? And maybe even separate this into separate lines, okay? Which actually, might allow you to very much easier to work with the array. Perhaps you want to put a random value in front of the array, right? One in front and one after, right? So for instance, so that now if I click on the add element, it'll add a random value at the top and a random value at the bottom. Somewhat silly. There it is, 97 and 0, 79 and 71, 89 and 6. Okay, so it's just wrapping these random values in front and after, keeping the old array in here. Okay. So let's look at the delete element. So the delete element is slightly different because, when I delete an element, I need to know which one are you removing, right? And for that, we are using the index, right? So notice that we are passing, when we click on the delete element, we are passing the index, okay? So when this gets rendered, right, and it's iterating over the UL, this is going to be, the first item, the second item, and so on and so forth. This is going to be delete element 0, then delete element 1, 2, 3, 4, 5, right? And once it's rendered, each event handler needs to remember what was the index when it was rendered at first, right? Because the index just keeps going up, right? You would expect maybe that once you get at the bottom, they're all going to be, delete element 20, right? But no, right? Each one remembers, right? And that's the beauty of what I mentioned earlier of the closure, right? The JavaScript closure is that, when you have these kinds of syntax, it remembers, right, the state of when the function was declared, right? So that it can recall that state and recreate that state and remember that index was 0 or 1 or 2 or 3 whenever that function was created, right? The value, the dependency is remembered so that it can use that and recreate that state to invoke the correct value, okay? All right. Okay. So let's take a look at, so we've talked about, pretty much everything you can do with state variables. So here's where the challenge starts to appear, right? That when you want to be able to not only have the state within the component, but you want to share that state with other components, right? Now, when it's a parent, if a parent wants to share the state with a child component, that's pretty simple, right? If it's a direct child, right? It's fairly simple to just pass those variables down to the child. The challenge starts becoming when it's not a direct child, but it's a grandchild or a great-grandchild, right? So you have a long hierarchy of components with children, with other children, with other children, right? And the parent having to talk to the great-great-great-grandchild, right? And back, where the state lives at the parent, but it is the leaves way down there that needs the state, right? So let's do a trivial example, right? And then the more advanced example, we'll leave it for Redux later this week, right? So let's create two trivial parent-child components. Let's recreate the counter, right? The counter example, but let's break it into two components, right? So let's create first the parent component. So here's the parent component, and let's put in here this code. There it is. Now, if I save it, it's going to break. Actually, no, it did, right? Because I'm not including it for rendering. But notice what's happening here, right? We are including a child component, which we don't have, and we are declaring a state variable, and then we're passing to our child component. We're passing the state variable plus the mutator function. See that? And the mutator function can then be used by the child to update the state. See that? All right, so let's create the child component. Let's create the child component. And let's see, new files, child component. Let's paste it in there. So again, we have the counter value that's being passed as an argument. We're also being passed this set counter, the same two buttons that we had earlier, right? But they live in the child. But the child is manipulating the state of the parent. The parent is maintaining the state, right? And this works fine. It's totally reasonable, right? So we have parent state component, and there it is, right? So it works the same way. If I increment, notice that the state changes in the parent and it changes in the child component. So they are truly sharing the state, even if it's a long hierarchy, right, of a parent sharing a state that is being drilled down all the way to some very, deep leaf in the DOM tree. That's okay. The state propagates across the components, right, and it renders just fine, right? And the implementation makes total sense, right? It is the parent who's maintaining the state. It's sharing functions and data with the children so that they can render the content, right? Not only I can render the content, the data, but also my children can render the content. Where's my state child? There it is. Receive it, render it to, right, and the child, but then the functions are being invoked on the parent. This is totally fine. It's totally reasonable. If it's just one component, including another component, that's totally reasonable. Like, for instance, a to-do list would be reasonable, right? That you have a parent to-do list, right? And you're iterating over multiple arrays of objects, each to-do list, to-do items, and you're passing the to-do to each of the to-do items for it to render. And then, you might have functions that, add to the array of to-dos, remove them from the array, or change the state as being done, or a due date, or whatever, right? And all these functions that manipulate the state can be passed down to the to-do item, because the buttons that you click to delete or to update or the count or the date picker, they all live in the children elements, right? They don't live in the parent. The parent's just maintaining the state, maintaining the array of to-dos, right? Plus all the functions that manipulate the array of adding new to-dos, deleting a to-do, updating a to-do, right? Setting it to done, changing the date. All those functions exist in the parent, right? But the events are being handled by each one of the children. So you would pass down all these functions down to the child, right, for them to invoke you and change the state in the parent. And then the parent re-renders, right, and repropagates all the state down to the children. So it's a very reasonable thing to do. The challenge happens when you have very long chains, right, of components, or even sibling components that want to look at the to-dos, right, and render them in some other screen, right? Well, now how do I pass it? How do I share the data of these to-dos when I want to render it in some other screen, right? And that's where the use of Redux comes in, right? And that's the reason that we're going to explore Redux to complement, to work together with useState, right? So that it can be, propagated across multiple screens, multiple components, right? By breaking the dependencies of how to maintain the state and how it's being rendered, right? Those are two entirely different responsibilities and skill set, right? And concerns, okay? All right. Oh, yes, I did want to point out something. These variables, the names that we are choosing here, counter or set counter, these names are entirely arbitrary, right? Nobody's enforcing these names, right? So I could have chosen, whatever, right, for these, and this would work just the same, right? This would still work the same. And these, for this, I also could have chosen anything here. So there is no enforcement for these functions. As long as you're consistent of how they're being used, it doesn't really matter, right? Nobody's enforcing you to call that set something, right? This is just a function that you can pass it along like any other function, right? And this is just a variable holding a value. Ideally, you would follow some naming convention that it's understandable. This question says, should we declare set counter function in parent or child component? Well, it has to be in the parent, right? Whoever is holding this state needs to hold it. There's no way for the child, for instance, to share the state with the parent, right? There's no, so only the parent can send down a state and pass down functions for then the children to invoke functions up to the parent, right? It says, but we still have to keep the counter and set counter in line 8. That's right. Yeah, because the child state, this here is expecting these names, but we could change that too, right? This could be, this could be ASD, and this could be, ASD. As long as you're consistent, this works just fine. Why it is in the children component? What do you mean, what it is in the children component? Why it is in the children? I don't understand your question, Shuan. Line 5 and 6. What about it? What is that you're asking about this? I thought set counter is somewhat built-in function of JSX. No, these functions are entirely made up, right? These functions. So useState. So what's happening is that useState is creating an array, and it's a function, right? It's a function, and it returns an array, and with 2 items in that array. The first item is a reference to an internal data structure that represents the data, right? That you can then use to render. Okay. Now the name that you give it doesn't matter, because these square brackets is basically a destructor, right? We are destructing the array that is coming, and then we are assigning it to these local constants, right? These local constants variables, right? QWE is holding a reference to the data structure that is holding the value of 1, 2, 3, or the current value. Whereas this WER, right, is holding a reference to a function that lives inside of useState, right? That we can invoke it, right? It's being passed to us through an array, and then we can invoke it, and we can pass it arguments to it to modify the internal data structure of QWE, right? And then it forces a re-rendering of the component, right? And then useState sends us back another array, right, with a new value of QWE, right, and the function that allows us to change that. So because it's square bracket, it's the square, the array destructor. The names of the constants is whatever we choose them to be. Now, if these were curly brackets, if this were an object destructor, right, then the keys are dictated by whatever the function returns, and we can't change those keys. Just like this ASD has to match this ASD. I can't change that. If I change this to something else, this doesn't work. It breaks, right? So this has to be in this, because it's curly bracket, it has to match the keys, right? And the keys, whoever's passing it called it ASD, right? So on the other side, when we destruct it, we have to maintain the names of those keys, but not so in the array destructor. It's by position, right? It's where am I in the first position, in the second position, right? In the object destructor, the position doesn't matter, right? I can change the positions, right? The positions don't matter. The names matter, but not the positions. Whereas in the array destructor, the position is what matters, right? Position 0, position 1, but the actual names don't matter. So it's the opposite, right? So yeah, but let's use useful names, right? But you can assume that I will be trying to fool you in the exam, right? You know, just to make sure you do understand that these are by position, right? So this is so so my quizzes always have a lot of gibberish variable names and function names, right? That you have to step through the code to understand what's happening, right? That if I use valid names like counter and set counter, the questions would be trivial, right? So by using gibberish names, you really have to analyze the code and understand what's happening, right? And truly come up with a solving the puzzle that I give you. All right. All right, folks. So up to here is where you can expect the midterm to be on, right? Using state variables, right? So state variables will have routes, right? We can navigate links, right? That you can pass parameters, right? You can pass path parameters, and then you can use use params to parse those, and then you can use location to get a path name, right? Passing things by attributes, right? And using all the various destructor syntax of array destructors, object destructors, right? So all that good stuff you can expect in the midterm. So we're all gonna practice that. We're gonna review that on Monday at the beginning of next week, right? And then the following towards the end of the week, the exam will be on. Okay. All right. I guess if we got to take a break today. Any questions? All right, then. Thank you, everyone. Good night.